Okay, so last class we did 2.1 and 2.2. So we were looking at transformations of quadratic functions and the different characteristics of their graphs. Today we're going to be talking about modeling with quadratic functions. So given different scenarios, writing the equations of the quadratic functions using what we know. So for example 1, if we're given a point and the vertex, then we can use vertex form. So what we're going to do, we're going to label our point is going to be x, y, and our vertex is hk. And so we're going to plug that into our vertex form right there. Y equals a times x minus h squared plus k. So I'm replacing y with -7 equals a, I don't know, so I'm going to find it. X I'm replacing with 1 minus h, so minus -2 is plus 2 squared plus k is 5. And then we're going to solve this for a. So simplify in the parentheses, 1 plus 2 is 3. I can take that exponent, make 3 squared 9, so that's like I have 9a. And now I have a two-step equation that I can solve. So subtract 5. We'll come up here. So -7 minus 5 is -12. And then divide by 9. So -12 divided by 9 is -4/3. And so to write the equation, then we're going to plug in a and hk. We'll leave y and x. So y equals a is -4/3 times x minus -2, so plus 2 squared plus k is 5. And that's our equation. Okay. Pause the video and try this example on your own. Okay, let's check it. So you should have started by plugging in x, y, hk. So you would get 8 equals a times 0 minus -10, so plus 10 squared plus -3, so minus 3. And then you would simplify. So 0 plus 10 is 10. That's 100, a, and then solve. So add 3. 8 plus 3 is 11. I'll come up here. 11 equals 100a. Divide both sides by 100. And that can't be simplified, so a is just 11/100. So y equals a is 11/100. X minus h, so plus 10 squared, plus k, so minus 3. All right, we can also see some real life problems with this. You're going to follow the same steps. We just have to identify what our point and our vertex is. So example 2, the graph shows the parabolic path of a performer who is shot out of a cannon where y is the height in feet and x is the horizontal distance traveled in feet. The performer lands in a net 90 feet from the cannon. So to write a function, again, we're using a point and the vertex. So this is our point, x, y, and this is our vertex, hk. So same steps. Plug in x, y, and hk. So 15 equals a times 0 minus 50 squared plus 35. And then we solve, or simplify, sorry. Well, no, solve. So -50 in parentheses, and then we square that, we'll get 2,500, and now we're solving. So subtract 35. And if I'm moving too quickly, you can always pause the video, come back, pause the video. All right, so 15 minus 35 is negative 20. And then divide by 2,500. I know those zeros cancel. And then 2 over 250, I can divide both of those by 2. So that'd be negative 1 over 125 for A. So my function is y equals negative 1 over 125 x minus h minus 50 squared plus k 35. Okay. What is the exact height of the net? So what we're going to do now is we're going to take, we have that the net is 90 feet from the cannon. So the distance x is 90. We're plugging that in to find y. So I'm using my function that I wrote, y equals negative 1 over 125 times x, so 90 minus 50 squared plus 35. And then we simplify. So negative 1 over 125, 90 minus 50 is 40, squared plus 35. Square that 40, that'll be negative 1 over 125 times 1,600 plus 35. Then we multiply, and I'm going to use my calculator for that. So that'll give me negative 12.8 plus 35, which is 22.2. So the height of the net is 22.2 feet tall. Okay, so that's if you're given point and vertex, you use vertex form. If you're given the point and the x-intercepts, then you'll use what's called intercept form. So if you remember from 2.1 and 2.2, same thing. Again, we're going to plug in what we know, and we're going to find our A. So intercepts are P and Q, and then we have x, y. So using intercept form, replace y with 14 equals, we don't know A, replace x with 3, minus p is 4, and then again in parentheses, x is 3 minus q is 10, and then we're going to solve for A. So simplify in parentheses, 3 minus 4 is negative 1, 3 minus 10 is negative 7, then we can multiply those. Negative 1 times negative 7 is positive 7. And just divide both sides by 7 to find what A is. So A is 2. So when we rewrite our equation, we leave x and y. So y equals A is 2, x minus p is 4, x minus q is 10. Okay, pause the video and try the next example on your own. Okay, let's check it. So you should have plugged in P, Q, X, and Y. then what that would look like is negative 11 equals a times negative 8 plus 2, because opposite signs, and then negative 8 minus 3. Then you would simplify. Negative 11 equals a times negative 6 times negative 11. Negative 11 equals a times positive 66. Divide both of those by 66. And then to simplify that, I know I can divide both of these by 11. So negative 1 over 6 is a. So y equals negative 1 over 6 times x plus 2 times x minus 3. All right, and then again, if we have a real world problem where we have the x-intercepts in a point, then we'll follow the same steps. So for example 4, a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. Write a function f that models the temperature over time. So we have a point x, y, and we have our two y-intercepts p and q. So we're just going to plug those in. So y is 9.6 equals, we don't know a. X is 0, minus p is 4. Again, x is 0, minus q is 24. So 9.6 equals a. 0 minus 4 is negative 4. 0 minus 24 is negative 24. Then we can multiply those. Negative 4 times 20, negative 24 is positive 96. And then we divide. So those cancel, and that equals 0.1. So a is 0.1, which means that my equation is y equals 0.1 times x minus 4 times x minus 24. So that's our function. Oh, since they said function, let's use function notation. So instead of y, we'll use f of x. Okay, so for our next example, it says, what is the coldest temperature? So I want to know this point right here, this vertex, right there. If you didn't have a calculator, you would use what's called completing the square, but I haven't taught that yet, and I'd rather teach that in person because it's a little more complex. So what we're going to do is we're going to practice with the calculator. So I'm actually going to graph this function. So in my calculator, y equals, let's clear that out. I've got 0.1 times x minus 4 times x minus 24. I'm going to graph it. I'm going to move my window. I want my window to kind of match what I have here. So my x values go from 0 to 24. And my y values go from about negative 15 to positive 15. Okay, and if I want to find that minimum value, I'm going to do second calc. I did not mean to click that. Second calc, go down to minimum, press enter. Left bound, I want to make sure that point right there is to the left of my vertex. So we'll go right there, press enter. Right bound, I'm moving it to the right of my vertex. So we'll go over here on this right side, press enter. And then it tells me my vertex is at the point 14, negative 10, if you see on the bottom of the screen. So 14, negative 10. which you can tell from the graph, but just to be careful, we wanted to check. So my coldest temperature is the y value of that point, negative 10 degrees Celsius. All right, part C. What is the average rate of change in temperature over the interval in which the temperature is decreasing? So over the interval in which the temperature is decreasing is from here to right here. That's that negative slope. And I'm going to label this point again. That was 14, negative 10. So average rate of change, that's just slope. So that's our y2 minus y1 over x2 minus x1. So first part, over the interval in which the temperature is decreasing, the left side of my graph. My 2 points that I'm going to use are the starting point. This will be x1, y1. And then my vertex, that'll be x2, y2. So plug that into your rate of change formula. y2 minus y1 is going to be negative 10 minus 9.6 over x2 minus x1 is 14 minus 0. Then we simplify. So negative 10 minus 9.6 is negative 19.6 over 14 minus 0 is 14. I'm going to use my calculator to simplify this. So negative 19.6 divided by 14 is negative 1.4. And then we always use the unit for y over the unit for x. So degrees Celsius per hour after midnight. So that's our first answer. Okay, and then it says, what is the average rate of change in temperature over the interval in which the temperature is increasing? So just looking at the right side of my graph here. So now, I use a different color, I use pink. This will be x1, y1, and this will be x2, y2. So I'm plugging that in. I'll have 0 minus negative, so plus 10 over 24 minus 14. So 0 plus 10 is 10 over 24 minus 14 is also 10. 10 over 10 is just 1. And again, degrees Celsius per hour after midnight is that unit rate. Compare the average rates of change. So looking at 1 and 2, it looks like you should obviously be able to tell that 1 is negative and 1 is positive, and that matches with decreasing and increasing. But also, you can tell that on average, it falls faster than it comes back up. So on average, the temperature falls more quickly than it rises back to 0. That's our third answer there. And that's it for 2.3.